Hello, good morning, class.
Good
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 morning,
morning,
morning.
Miss.
Miss.
Good
Good
morning.
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 Nice to meet you again. How are you today?
We
We
are
are
fine,
fine,
We are
Miss.
Miss.
fine.
Okay, good. Before we start today's lesson, let's pray together.
Before we start today's lesson, let's pray together. Praying start. Praying enough.
Okay, done. Is anyone absent today?
No, Miss.
Okay, good. Today we are going to continue our lesson about electrochemistry. Do you have read the material about it?
Not yet, Miss.
I have read it but not finished, Miss.
It's okay. Before we start our lesson, I wanted to ask you, do you have seen battery in your life?
Yes, Miss. Battery is usually used on television remote.
Yes, that's right. Battery is just like everything else in life. It's just chemistry raised to the power of awesome. Now look at the picture. What did you see from the picture?
Battery has two poles. There is positive terminal and negative terminal, Miss.
Okay, good. Any other opinion?
Battery has composition of zinc, manganese oxide, and there is also cellulose barrier.
Okay, you're right. The kind of chemistry that happens inside of a battery is called electrochemistry, which will be discussed today. Before that, I'll share my PowerPoint here. So there are learning goals. Okay, the learning goals are first, you should be able to describe electrolytic cells and the redox reaction occurring at the anode and cathode during electrolysis. Second, calculate it by using Faraday's law. Third, define standard electrode potential and standard cell potential. Fourth, calculate a standard cell potential by combining two standard potentials. Fifth, use the Nernst equation to predict quantitatively how the value of an electrode potential varies with the concentration. Okay, before we start, do you still remember about the redox reaction that we discussed earlier?
Yes, Miss. There are two solutions for redox reaction: Hopf equation and concept of oxidation number, Miss.
That's right. So make sure that you still remember about the redox reaction before continuing with this lesson. Okay, let's move on to our lesson. I wanted to ask you, based off the name, in your opinion, what is electrochemistry?
Electrochemistry is chemistry in electricity.
Yes, that's exactly right. But specifically, electrochemistry is the relationship between chemical reaction and electricity. When we are studying electrochemistry, there are basically two main ways that chemical reaction and electricity interact.
What is the relationship between chemical reaction and electricity, Miss?
Good question. There are two applications of electrochemistry that will be explained today. The first is electrolysis. Now look at the picture and analyze. What are the parts of electrolytic cell?
Electrode, electrolyte, and power supply, Miss.
Good. There is right answer. In the electrolysis cell, there are electrolyte is the compound that is just liquid or solution that contains an ionic compound. The power supply, which is must be direct current, and the electrode. Based on the picture, what is the type of electrodes?
Positive electrode and negative electrodes, Miss.
Good. What is the name of the positive electrode in electrolysis?
Not miss.
How about the negative one?
Cathode, Miss.
Based on the picture again, what is the direction of the flow of electrons?
Based on the picture, electrons flow from the anode to the cathode, Miss.
Okay, good. Based on this answer, who can conclude what is electrolysis?
Miss, electrolysis is the composition of a compound into its element by an electric current with electron flow from the anode to the cathode, and the reaction requires a power supply.
That's right. Do you have any question about the electrolysis cells?
Enough, Miss.
Okay, next we will discuss about redox reaction in electrolysis. So let's get started by watching this animation. Based on the animation, what is the electrolyte type of the electrolysis cells?
Zinc chloride, Miss.
If zinc chloride dissolves in water, what ions are present in the solution?
Zinc ions and chloride ions, Miss.
That's right. The ionization reaction will be like this, isn't it?
Yes, Miss.
All right, Miss.
Okay, now look at the animation again. Based on the animation, which species acts as cathode and anode?
Cathode is the positive ions, which is zinc ion, Miss.
Okay, thank you. What happens at the cathode?
Cathode gains electron from the anode, Miss.
Okay, good. What reaction will occur if the species gains electron from cathode?
Reduction, Miss.
That's right. How about anode?
They lose electron to the anode, Miss.
What reaction will occur if species lost electron from anode?
Oxidation, Miss.
Good. So how is the reaction at the anode and cathode of zinc chloride?
I want to try, Miss. Miss, this is
That's right. The electron loss at the anode balances the electron gain at the cathode, isn't it?
Yes, Miss.
Okay. Do you have any question about reaction in electrolysis?
So, electrolysis reaction is always redox reaction, Miss.
Yes, that's right. During electrolysis, the positive ions or cations move to the cathode, and the negative ions or anions move to the anode. In the cathode and anode may be gained or lost in redox reaction. So, electrolysis reaction always implicate redox reaction. Did you understand about it?
Yes, Miss.
Okay, if you already understand about electrolysis reaction, now look at the animation again. What do you get at the cathode?
Zinc is deposited at the cathode, Miss.
Yes, that's right. If we pay attention, mass of the zinc begins to erode with time, isn't it?
Yes, Miss.
How about anode?
at the anode. Gas bubbles form at the anode, Miss.
Yes, right. The bubbles come from chloride gas as a result of the oxidation reaction of chloride ions. Does that mean the mass at the anode increase, right?
Yes, Miss. Mass at the anode increase.
Okay, good. The mass of a substance can be produced or removed from an electrode during electrolysis. Now, we will learn the calculation of the electrolysis reaction, which are called the Faraday's law of electrolysis. So, The first law given by Faraday was the was that the total mass of a substance which is deposited on an electrode is directly proportional to the amount of charge passing through the electrolyte. The mass of a substance produced at the electrode during electrolysis can be calculated by like this. The quantity of electricity is often expressed in terms of a unit called the Faraday. 1 Faraday is the quantity of electric charge carried by 1 mole of electron or 1 mole of singly charged ions. Its value is 96,500 coulomb. So, look at the reaction of zinc chloride again. Who can write the reaction in the cathode on your notes?
Me, miss. Is it like this, miss?
Okay, thank you. Now look at the screen. Based on the reaction, how many mole of zinc are formed?
1 mole, Miss.
Yes, that's right. So, how much the electric charge carried by the electrons in the reaction?
1 Faraday, miss.
Remember, how many coulombs is the value of 1 Faraday?
Oh, 96,500 coulombs, miss.
Yes, that's right. So, 1 Faraday of electricity or 96,500 coulombs is required to deposit 1 mole zinc. Have you understand about it?
Yes, miss, I have.
Okay, Fadila, you can take it down. Okay, if you already understand about electrolysis, let's move on to another application of electrochemistry, namely cell voltage. Before we get into the material, the first we will discuss about electrode potential.
Okay, now look at the animation. Okay, based on the animation, if we dip an electrode in its solution, electron can flow to or from the solution to the electrode. That means the electron can either lose electron or gain electron. This can build up the charge cause an electric potential or voltage between the electrode and ion metal in solution. When the electrode loses electron, the reaction is considered as oxidation reaction, and the potential of the electrode is known as oxidation electrode potential. Similarly, when the electron gains electron, the reaction is reduction reaction, and potential is reduction electrode potential. Do you understand?
Yes, miss.
Okay, if you understand, can anyone conclude what is electrode potential?
Permission to answer, Miss. I think electropotential is electrical potential at the electrode when electrons flow to or from the solution to electrode.
Yes, you've got it. So, electrode potential is the tendency of the metal or lose or gain the electron when it in contact with an electrolyte. When a metal is put into a solution of its ion, an electric potential is established between the metal and ions in solution. Reminder, electrode potential value give us an indication of how easy is it to reduce a substance.
Permission to ask, miss. Is there only the reduction electrode potential, miss?
Oh no, but by convention, The electrode potential refers to the reduction reaction. If you want to use oxidation electrode standard, you can change the sign from potential standard V2. For example, if we have reduction electron potential of argentum is positive 0.8 volt, so oxidation electron potential of argentum is negative 0.8 volt. Do you get it?
Mm, yes, Miss.
Miss, how to calculate the potential of electrode, Miss?
That is good question. We cannot measure this potential directly, but we can measure the difference in potential between the metal or metal ion system. To determine the potential of an electrode, we should use standard condition when comparing electrode potential. The electrode potential we measure is called the standard electrode potential.
What is the standard electrode potential can be used, Miss?
Okay, that is good question. Standard electrode potential can be used as standard hydrogen electrode or SHE. The SHE consists of platinum wire that is connected to a platinum surface with an aqueous solution containing 1 molar of hydrogen ions in equilibrium with hydrogen gas at 1 atmosphere. To understand it, please look at the animation and see what happens at the standard hydrogen electrode. Okay, based on the animation, what happens at the standard hydrogen electrode?
Hydrogen gas is bubbled around a platinum electrode, Miss.
Okay, any other opinion?
Uh, Based on the animation, hydrogen gas can be oxidized to hydrogen ions or hydrogen ions can be reduced to hydrogen gas, Miss.
Yes, that's right. Based on the animation, platinum electrode can surface catalyze the oxidation of hydrogen molecules to hydrogen ions or reduction hydrogen ions to hydrogen gas. Therefore, at the electrode, hydrogen gas can either be oxidized or hydrogen ions can be reduced. Now, who can write the reaction at the electrode?
I want to try, Miss.
Okay. Right, this reaction is assigned by standard electrode potential, with standard potential hydrogen is 0.00 volt. Do you understand, class?
Yes, Miss. I've got it.
Okay, if you got it, you can measure the standard electrode potential of cells. Okay, based on the picture, we can know how much potential standard
Yeah.
value for a half cell of copper, isn't it?
It is
Now,
0.34 volts.
Why do you answer like that?
Because the value is can be read in voltmeter, miss.
Okay. But that is value of the potential cell between ions of copper and standard hydrogen electrode. Because the voltmeter shows that the standard cell potential of a galvanic cell consists of a standard hydrogen electrode and a half cell of copper. But now listen the question. How much potential standard value only for a half cell of copper? Always in mind, what is the potential standard value of hydrogens to answer it?
Oh, I see, miss. Potential for potential value of hydrogen is 0 volt. So, if a half cell of carbon is connected to standard hydrogen, the voltage is positive 0.34 volts.
Why do you answer like that?
Because based on the picture, the copper is positive terminal miss and the hydrogen electrode is the negative terminal. So, electron are moving from hydrogen electrode to copper electrode, and hydrogen is being oxidized because loose electron, and copper is reduced because gain electron from hydrogen electrode. Because copper is reduced, so potential value for a half cell of copper bigger than hydrogen is.
When the electrode potential is negative, so the more difficult it's to reduce the ions. Because copper is reduced, so potential standard value for a copper half cell bigger than hydrogen.
very good
Therefore, the
explanation.
resulting
So the
value
more
is
tinggi
positive.
the more
Do you
positive the
understand?
electrode potential, so
Yes,
the easier
Miss.
it's reduce the ions.
Okay, if you understand, please write the reaction in note.
This is Miss.
Okay, that is good. It seems you really understand about the standard potential value of electrode from a half cell. And then we will learn how to using potential standard value to predict cell voltage. Okay, what do you know about potential standard value to predict cell voltage?
We can use potential standard value to calculate the voltage of an electrochemical cell made up of two half cell Miss.
Okay, that's good. And the voltage measure is the difference between the potential standard value of the two half cell, or we can call this value a standard cell potential. And then look at the screen. In the screen, we can see the potential standard cell of the equation of potential standard cell, which is a derajat cell equal to a derajat reduction substrate to a derajat oxidation. Do you understand, class?
Yes, miss.
Yes, miss.
Okay. Now, look at the picture of electrochemical cell. What is the chemical equation for the cell?
I want to try, miss.
Okay.
Uh, is this?
Okay, good. Does anyone know the voltage of the cell?
Hmm.
Okay, it seems you guys doesn't know it yet. I will explain how to calculate the cell voltage. It is by subtract the higher value from the lower value. And then CP, how much the cell voltage of this chemical reaction?
The cell voltage is plus 0.80 minus negative 0.76 volt equals plus 1.56 mis.
Yes, good job, Siti. Any question, class?
No, miss.
No, miss.
Next, we will discuss the direction of the flow of electron in the wires of an external circuit. Pay attention to following equation. Based on the screen, what can you observe on this reaction?
The relative values of this voltage tell us zinc ions are more difficult to reduce than argentum ions, Miss.
Okay, Septi, and then Umi, what happens when zinc ions are more difficult to reduce than argentum ions?
Zinc metal will lose electron to the argentum half cell, and argentum ions will accept electron from the zinc half cell miss.
Good job. And the electron flow is from the zinc half cell to the argentum half cell. So what is the conclusion about the direction of the flow of electron in the wires of an external circuit?
The electrons fall from the negative pole to the positive pole, Miss.
Yes, that's good. Next, we will discuss about how to calculate the cell potential using a Nernst equation. So the next equation gives an idea about what to be cell potential or what will be the electrode's potential on cathode or anode with its concentration of the product or with reactant. Now look at the screen. Let us take an example of reaction. Based on the reaction, if concentration of zinc is greater than 1 molars, the value of potential standard becomes more positive. But if concentration of zinc ions is less than 1 molars, the value of potential standard becomes more negative.
Why did it happen, miss?
Okay, we can apply Le Chatelier principle to redox equilibria. If we increase the concentration of the species on the left of the equation, the position of equilibrium will shift to the right. So the value of potential standard becomes more positive. Any question, guys?
Miss, how does the concentration change affect if the conditions are not standard for the whole cell?
That's a good question. Now, look at the screen. Now, the effect of a concentration and temperature on the value of potential standard cell can be found using the Nernst equation, which is like on the screen, where E is potential standard potential under non-standard condition. E derajat is the standard electrode potential. R is gas constant. T is Kelvin. Z is the number electron. F is the value of the Faraday constant. Ln is the natural logarithm. And concentration oxidase refers to the concentration of the oxidase formed in the Hobbes equation. Any question, guys?
No,
Enough,
miss.
No,
Miss.
miss.
Okay, let's try to calculate the value of the electrode potential on the screen. Who want to try it?
I want to try, miss. This is.
Okay. It's a good answer. until heat. Is everything clear?
For me, it's clear, Miss.
Okay, it seems you really understand about electrochemistry. If there are enough, we can conclude our material today.
Electrochemistry is the relationship between chemical reaction and electricity. There are two applications of electrochemistry, which is electrolysis and galvanic cell mist.
Okay, that's good. Okay, it's enough for today. I really hope to see you next time. Thank you, class. Good morning.
Good morning,
Good
Miss.
Morning.
morning.
Thank
Thank
you.
you.